Hello, everyone. So in this video, I'm going to be going through the section 1.3 guided notes with you. So I'm going to go ahead and share my screen here, and we'll get started. Okay, so to access your guided notes, so you want to go under the modules page on Canvas, and then you want to go in section 1.3 lecture materials. And then in here, you can find the blank version and the filled in version since we didn't have class today. So I'm going to go ahead and open the filled in version, and that's what I'm going to be talking through today. So section 1.3 is about the process of a statistical study. So the first thing we're going to talk about here is how a statistical study is conducted. So the first step is to design the study. So there's 4 steps to that. So you want to state the question to be studied. So to give an example, like you may want to know, let me think of an example here. Like, what is the effect of a certain diet on weight loss or something? Or there's a million different questions that you could ask and conduct a statistical study for. Or what is the average age of community college students in the US? Something like that. And then you're going to determine your population and your variables. So what is the large group you're going to be picking a sample from? And then what is your variable for your study? So like from the average age of community college students, the variable there would be age. That's the subject of the study. And then determine the type of study, observational or experimental. So that is going to depend on what you're looking for. We're going to talk more about the difference between these two in a minute. And then you're going to pick a sampling method. After you design your study, then you're going to collect your data, and then you're going to organize your data, possibly into like a graph or a table, just to make it visually appealing to the viewer and able to be interpreted. And then you're going to analyze the data to answer your question. So that's the general process of a statistical study. You're going to be doing this when you do your project in this course. So let's talk about observational studies first. So what is an observational study? So an observational study observes data that already exists or collects information from participants without intervening. So you're simply observing and collecting data. You're not intervening in any way or having any influence on the data. You're just simply looking at what's already occurring and collecting the data. This is fairly common. There are cases where experiments are needed, especially to determine a cause and effect relationship. So you cannot determine a cause and effect relationship from an observational study because you're not intervening in any way. You don't know what other outside factors could be contributing. So for that reason, an observational study just can only collect information as is and cannot determine whether one variable is causing the other to occur. Which not every study is looking for a cause and effect relationship, so that is okay. If you wanted a cause and effect relationship, you would need to make sure that you have controlled groups to compare. So like, for example, a drug study, like a placebo group, and then a drug group, so that the only difference between those groups is the drug, and you can actually attribute the drug to causing, healing or whatever the situation is. If you did not have those separated, distinct control distinct groups, then you don't know what other factors could be causing whatever effect you think the drug is doing. So you aren't able to make that direct comparison between the people who are taking the pill and aren't taking the pill. So some examples of an observational study: using emissions data to determine the average age or the most popular major of Carroll Community College students. So that's just looking at and collecting data and then using it to calculate something, but there's no cause and effect relationship desired there. And then taking a study to ask Carroll Community College students their favorite ice cream flavor. So once again, no manipulation or intervention, just looking at and collecting data. All right, so let's now discuss the different ways you could take a sample. So first thing we want to talk about is a representative sample. So a representative sample has the same relevant characteristics as the population, and does not favor one group over another. So for example, if the population is half women, so should be your sample. So that is ideal. You want your sample to look like just a smaller version of your population. That is your goal. And then random sampling. So this is a sample of 1. So every member of the population has an equal chance of being selected in random sampling. So picking a student in our class by picking a name out of a bowl would be an example, or using a random number generator to select a student in our class. This is specifically referring to selecting one person. So it's more about the process of random sampling is more a process versus the actual sample collected. So simple random sampling is actually what we're talking about. We're actually collecting a sample using the process of random sampling. So simple random sampling is selecting a sample using random sampling, basically. So every sample has an equal chance of being selected. Basically, it's random sampling for more than one person. So to give some examples there, so selecting 5 students from our class by picking a name out of a bowl or using a random number generator. And in that situation, every 5 student combination should be equally likely to be chosen because everybody's equally likely to be chosen in the population. So that is an example of a simple random sample. That is the most ideal. It's completely random, no bias involved, but that is normally not practical in reality. But simple random sampling is the most ideal type of sampling. So this is the kind of an outline of the process of simple random sampling. So you could assign numbers to all members of the population, then select numbers using a random number generator, and then that would create your sample. So that would be an example of a simple random sample. So stratified and cluster sampling are very close. So stratified sampling is when you select a few members from each stratum or group randomly. So the process of this is that you divide the population into groups. And then once they're in separate groups, then you take a proportionate simple random sample from each group. What I mean by proportionate is you take more from the larger groups and less from the smaller groups. Basically, the amount you take from each group is proportionate to its size. So a good example of this would be splitting a high school into groups by grade and then taking a proportionate simple random sample from each group. So stratified sampling, in summary, you split the population into groups and then you take some from every single group. Versus cluster sampling, all members from a few of the groups are selected. So it's still everybody's divided into groups, but then you're going to take a simple random sample of the groups and select everybody from the selected groups for your population. So for example, this is an example here. So this garden here was split into groups by plot of land, and then a simple random sample was taken of the plots, and every plant in these particular plots that have the red box would be part of the sample. So the biggest distinction is you take some from every group in stratified. So that's what's kind of outlined here, a few members of each group. And then in cluster sampling, you take each member from a few groups. So in other words, stratified is a little bit better. Stratified is probably the next best after simple random because you're getting some from every group. Cluster though, so it can have some bias to it simply because you're leaving out groups of the population since you're only selecting particular groups and using everybody in those groups. So there can absolutely be some bias in cluster sampling. So systematic sampling, so this is every nth member of the population is chosen. I think of an assembly line first thing when I think of a systematic sample. Every 4th item on assembly line, every 3rd person in line of store, that's all examples of systematic sampling. And you can see this assembly line kind of shows that here. This is a pretty good approach because it's still somewhat random, so it doesn't have too much bias in it. Convenience sampling, though, this is definitely not going to make a representative sample. The sample is chosen because it is convenient to the researcher. A good example that would just be picking the first few students to come to class for a survey. You're not attempting to make it random. You're just picking the people that are easiest to you. Now, this can be, there are times when this has to be done. Like, I think of like if you had a gigantic pile of heavy rocks. you would have to take the ones at the top practically. You can't really make it random. And sometimes, like when you're doing your statistical research study, it's probably going to be a convenient sample that you're going to end up doing just because of the practicality of what you're doing. But in general, you want to try to avoid this type of sample in actual research in reality. And then another type of convenience sample is a self-selected sample. So survey participants volunteer to be part of the study rather than having been chosen by the researcher. Once again, not really representative because you're going to get more of certain types of people, especially those with strong opinions. They're going to be the ones more likely to volunteer. So think of like even Google restaurant surveys. So a 5-star restaurant, or I'm sorry, a 5-star review and a 1-star review are probably going to be the most common. People are probably going to take the time to put a review if they were either really happy or really not happy. So that's prove any self-selected sample. People have to be motivated to do it. So for that reason, it's not usually going to be representative of the population. And so then here's some practice here. So I recommend before you look at these answers that you go through this yourself. So pause the video, don't look at the answers, and then come back and I'll talk about the practice. So I'll give everybody a second to pause. All right, so after you've done that practice, so the first example, students are divided according to major. The students are proportionally selected from each major and asked how often they use the library. So the key here is, so the groups here are the majors, right? So we know since it's groups, it's either got to be stratified or cluster. But then students are proportionally selected from every major because they're coming from every major. So that is very similar to this example here, where we took some from all of the grade levels. So that is a stratified sample. Letter B, a researcher stands outside of the library and asks 30 students how often they use the library. So this is convenience. They're just asking the first people they see. They're not really attempting to make this random. That's definitely a convenience sample. And then a researcher asks every third student waiting in line at the cafe how often they use the library. So every third student is the key there. That's systematic. And then letter D, students in our class are numbered. Numbers are selected using a random number generator, and the students are asked how often they use the library. That is definitely a simple random sample. Everybody's equally likely to be selected. You're just picking people randomly, no groups, nothing like that. It's just completely random. And then after a hurricane, a disaster area is divided into 200 equal grids. 30 of the grids are selected and every occupied household in the grid is interviewed to help focus relief efforts on what residents require the most. So we have 200 equal grids. Those are the groups. So we know it's either stratified or cluster. And then we select 30 of the grids. So we selected 30 of the groups and then we include every household in those groups as part of our sample. That is cluster. We took a sample of the groups instead of taking some from every group like you would in stratified. All right, so those are the different sampling methods. So let's talk about kind of different types of observational studies now. So in a cross-sectional study, data is collected at a single point in time, versus in a longitudinal study, data is gathered by following a particular group over a period of time. So a cross-sectional study example, so data collected at a single point in time, kind of like a snapshot or a screenshot. So a May 2024 survey asking which presidential candidate people prefer. So that is taken at a single point in time, right? May 2024, that's what makes it cross-sectional. Polls and surveys are almost always cross-sectional. They're given at one point in time. Versus a longitudinal study, it follows a group, like I said, over a period of time. So for example, this is an actual example, real-life example of longitudinal study. So the National Longitudinal Study of Adolescent to Adult Health follows a group of students from grades 7 to 12 over 14 years to see health changes as they transition into adulthood. So since they're following them over 14 years, that makes it longitudinal. And like with the last practice, if you want to pause and try these yourself before I go over them, I recommend that. So if you want to pause it for a second, go for it. Okay, so a group of 300 patients is followed for 10 years to determine the long-term health effects of steroid injections used for migraine treatments. So this is a longitudinal study for the reason of you're following them over 10 years. That is the key word. You're following them over a period of time. And then a cross-sectional study. So this is a survey at a single point in time because they're serving them 3 months after their last steroid injection. That is a single point in time. That's cross-sectional. So continuing on with the types of observational studies. So a meta-analysis. So this is a study that compiles information together from previous studies. So we're looking for some sort of trend or pattern across many studies on the same topic. So by putting the several studies together, you get kind of a larger sample and a better picture. So this is only as good as its most poorly constructed study, obviously. So you want to make sure that you have high quality studies included in this. So for example, if you were interested in studying how administrators respond to assault instances on college campuses, you could perform a meta-analysis of all the research done on assault on college campuses. So you could combine all the different research studies on assault on college campuses to get yourself a bigger picture of the situation. And then a case study is looking at multiple variables that affect a single event. So this is looking in depth at one event. So for example, if you were interested in studying a particular assault incident at a college campus, then you could perform a case study on that one particular incident. So the case study is extremely focused on one single event. So we have some more practice on page 5. So if you want to pause and try that first, and then I will come back and discuss the answers here. Okay, so the first one here, so a team of researchers look at multiple studies performed on a new migraine drug to determine whether the drug is safe to put on the market. So this one is going to be a meta-analysis because the key is you're looking at multiple studies. You're putting multiple studies together to form a larger conclusion. And then meteorologists studied the Indian Ocean tsunami of December 2004 to try to identify warning signs. This is focused on just this specific tsunami. So for that reason, that is a case study. So we've talked about observational studies. So the first half-ish of this set of notes, we focus just on observational studies, different types of sampling, and then the different types of observational studies. So we're now going to branch off into what experiments are now. So an experiment generates data to help identify cause and effect relationships. So the researchers control the groups and which group does what to establish this relationship. So their goal is to have two groups or usually two groups, one that, has the treatment and a control group. And then by controlling the groups and saying this group does this group does this, they are able to then compare the groups and understand that the only distinction between those groups is the pill they took, the treatment they got, whatever they did. So they're able to say, okay, comparing this group that I know that I assigned to do this and this group that I didn't assign to do anything, I am able to make a conclusion that this drug actually works. So this helps you identify cause and effect relationships because you are controlling the group and which group does what. So an example of an experiment, does a specific vitamin supplement help migraine symptoms? So we're going to use this example for the rest of the definitions, but we're looking for cause and effect relationship, right? Does the vitamin supplement cause the migraine symptoms to decrease? So the subjects of an experiment are the participants. So in this situation, your participants would be people who suffer from migraines. And then the treatment is the condition that it is applied to one of the groups in the experiment. So in this case, the vitamin supplement is going to be applied to one of the groups in the experiment. And then the response variable, so that's the variable that responds to the treatment. And then the explanatory variable is the variable that causes the change in the response variable. So in other words, the use of the vitamin supplement should be causing the migraine symptoms to decrease. So the explanatory variable should be influencing the response variable. And then the control group. So I kind of talked about this a little bit earlier, but that's a group of subjects where no treatment is applied. So the group that gets the placebo or the fake pill that looks like the vitamin supplement would be the control group. And the treatment group is the one that actually gets the treatment, the one that gets the vitamin supplement. So since we're talking about the word placebo, so a placebo is a substance that appears identical to the real treatment, but doesn't contain any intrinsic beneficial elements. So a sugar pill, for example, it's looks like the vitamin supplement, but it's really not. So the purpose is you want everybody in the experiment to think they're getting the treatment in order to be able to make a good comparison between the two groups. You want everybody under basically identical conditions, and only you really know that this group didn't get the pill and this group did. So the placebo effect, you've probably heard this term before. So this is a beneficial effect produced by a placebo drug, which cannot be attributed to the placebo and must therefore be due to the patient's belief in that treatment. So in other words, they get better simply because they believe they took the drug, not because the drug did anything. So that's why you want both groups to think they took the pill to control for the placebo effect. So for example, the control group may think they had a reduction in migraine symptoms because they think they got the vitamin supplement, but we know they really didn't because they didn't actually get the vitamin supplement. And then confounding variables are factors other than the treatment that could cause an effect on the subjects. So diet, stress, exercise, this could all affect migraine symptoms. So of course, confounding variables still have an impact in an experiment, but the hope is with an experiment that by controlling the groups that you were able to mitigate that as much as possible. In an observational study, when you're just collecting data, you don't have as much control over the subjects, so you really don't know who's doing what, and you're not really able to make a solid comparison between the groups because you're not controlling who takes the pill and who doesn't, etc. Okay, so this is just a diagram of how an experiment works. So you take a sample, then you randomly assign people to the control and the treatment group. The control group receives a placebo, the treatment group receives the treatment, and then you're able to then make a comparison and say the treatment group, hopefully does have a more beneficial effect than the control group. So a single blind or double blind experiment. So single blind experiments, the subjects don't know if they're in the control group or the control group or the treatment group, but the people interacting with the subjects do know what group they've been placed in. So this is decent, but of course you really don't want anybody to know because you don't want any sort of bias in the study. And then a double-blind experiment, neither the subjects nor the people interacting with the subjects know to which group each subject belongs. So double-blind studies definitely reduce bias because nobody really knows what the group, everybody is pretty much anonymously recording data. Okay, so principles of experimental design. So this is sort of how it's conducted. So you're going to randomize the control and treatment groups. You control for outside effects on the response variable as much as you can, and then you replicate the experiment to see any meaningful patterns. So assign your control and treatment groups, control as much as you can for any sort of confounding variables, and then you want to, of course, you want to do it multiple times just to see how that goes. Okay, so there's an example that follows this, and so I'm going to give you a second to pause to go through and try this example yourself. And then you can resume and I will go ahead and discuss it. Okay, so neurologists want to study the effect of vitamin C on nerve disorders. The goal of the study is to see if taking an intravenous dose of vitamin C will reduce the amount of nerve pain reported by patients that have MS. So after study approval, the neurologist solicits volunteers who are patients with MS that are reporting nerve pain. So they're randomly assigned to two groups, each with 20 participants each. So group A gets vitamin C and group B gets saline, which has no active ingredients, and their pain levels are tracked. So they're not told what group they're in. The nurses know the groups. because they're administering the IVs. I guess they sort of, well, they don't necessarily have to, but they do know here. And then the amount of pain reported by the separate groups is compared to determine if the vitamin C actually reduces the nerve pain. So the population of interest here. So our population would be MS patients, right? Everybody who has MS, they're the ones who are, that is the large group that the patients were taken from for this study. Is it an observational study or experiment? It's definitely an experiment. So we're specifically controlling the groups. We have specified treatment and control. So we're not just collecting data, we're specifically manipulating the subject, saying you're a control group, you're in the treatment group, which is enabling us then to basically control for outside effects as much as possible and actually make a direct comparison between the treatment and the control group. And then explanatory and response variables. So the explanatory variable, so that's receiving vitamin C, and then the response is the amount of nerve pain. So the explanatory variable, as a reminder, influences the response variable. So whether they receive vitamin C or not is going to influence the amount of nerve pain they have. And then the treatment here, so that is what is the active or the treatment group receiving. They're receiving intravenous dose of vitamin C. And then the treatment group would be group A, the ones that are receiving the vitamin C. Control group is the group with the saline. And then what is the purpose of administering saline to group B? So we talked about this a little bit. You want to control for the placebo effect. You want everybody to think they are actually receiving vitamin C. That way that you're eliminating any sort of bias as much as you can, and everybody is hopefully on a pretty equal playing field so you can make a good comparison. And then is this a single blind or a double blind study? So it's only single blind because the nurses do know the assignments. The participants don't, but the nurses do. Double blind is, of course, better if possible to avoid researcher bias. You don't want the researchers to be biased when they're collecting the data. You just want them to collect it factually and anonymously. And then the last final definition. So an institutional review board is a group of people who review the design of a study to make sure it is appropriate and that no unnecessary harm will come to the subjects involved. This is usually made up of people from whatever institution the study is conducted in, so like a university or workplace. So of course, this is important for ethical considerations. All studies need to be ethical and not cause harm to people or any sort of participants. And then informed consent is disclosing to participants the goals and procedures and obtaining their agreement to participate. There, of course, can be gray areas here, and this is definitely debated, such as with children, people with intellectual disabilities, animals, things that can't consent. So there's always debates on whether it is ethical to actually conduct research on those people or animals. So that is section 1.3. So after you've gone through the notes and you've gone through this lecture video, you should then be able to complete the Hawks online homework for section 1.3. If you would like to go through the learn and practice on that, you're welcome to do that also before you go into the Certify. And remember, use the Hawks single sign-on link to access that homework assignment. If you have any questions, please feel free to reach out. And I will see you for the next video on section 1.4.